Hi all, Vidura here. Short update. I made some tests more with the same setup as the last time. Only I have changed the load. I'm changing the impedance, putting more or less of these filament lamps in series. And by using this 1 kilowatt lamps, also the heating effect is much less than with the small 150 watt version. This also has caused to disappear some of the observed effects. Now, for example, it's quite pretty in phase, the output with the measured electric field. What I have noted that when I change the impedance of the load, when I lower the impedance, that I get a lot of bouncing of a subharmonic in the output coil. When I investigated a little bit further this thing, I found that it is related to the tuning of the Kacher circuit, of the Kacher resonator. I found this when trying the effect of the copper pipe. I have made here a copper pipe which I can slide in and out. We'll see when in the first sector, when I introduce the pipe into the current node, you can see there is a slight increase of the amplitude of both, and also the drawn current increases as when I slide in the pipe, the input impedance goes down, obviously. It's in a certain point only. When I continue to introduce the tube, then when I come near to the feeding point with the tube, then happens this, which I found something interesting, because the subharmonic is influenced without any change nearly in the fundamental resonance wave. When I continue introduce the tube going into the hot end of the resonator, then the whole thing becomes a little bit distorted. There is some effect. Also in the subharmonics, I can do something like a fine tuning by sliding the copper tube, but the input current remains stable in this part. There is no change. The only place where I noted the change in the input current, in the drawn current of the circuit, is in the first part, in the first few centimeters in the current node. You can see here. Now I'm at the very end of the pipe. Now I introduce it. You can see how the current increases and then it falls again. It's only in a certain point in the first 2 or 3 centimeters of the coil where the input current increases. And on the scope it looks like this. And the effect noted, which is only present on the subharmonic, is at the feeding point, in the area of the spiral coil which is driving the Kacher resonator. I can tune it to get the maximum of this subharmonics here. And the copper pipe is here over the feeding coil. So now I change the tube to the other side, to the hot end of the coil. Everything else remains the same. 1.1 amps more or less. Now I will introduce the pipe into the coil slowly. We got here more or less in this area. We have an increase in the amplitude also, and like before also the amperage drawn went up a little bit. It's a little bit less prominent than on the cold end, but it's also present. If I continue to introduce, there is also, when I reach the feeding point, there is some response on the subharmonic also. Here in this area, this is when it reaches the feeding, the exciter coil of the Kacher. Now I will introduce it completely. The current remains quite constant. There is only the increase in the first part of the hot end also, like on the other side. Note that the coil is in quarter wave resonance. So we have here the cold end, the current node, and here the hot end with the most intense field. Get some burning through the neon. Yeah, the most intense field is here in the antenna coil. Can show you the intensity of the Kacher. It arcs like nearly 1 centimeter. This fed with 12 volt with this battery direct. Short update with these tests. What I have done now, I replaced the spiral antenna with an internal antenna, an internal spiral into the bifilare inductor, and noted that the transference is much better. So now finally I get some result on the transfer of the high frequency to the other coil, which I was looking for the last time. So I will show you on the scope. I have now the push-pull on. It's about 170 volts, 180 volts. Would be something like this, peak to peak. So I will now power on the Kacher coil, and you can now see clearly that I have a response here. My signal generator, which I'm using now, is limited. I cannot reduce the duty cycle because I don't have more channels for this. But if I change the phase angle, you can see how it goes on the negative side in the other direction. So this would be an indication that the driving should be parametric. It should be a quarter of period, not half of the period, right, like it is right now. Another thing I noted, that due to the layout of the inductor, only it goes only in 1/2 cycle where the energy can received due to the polarity of the push-pull. You can note that I have no effect in this side of the sine. I can change the phase angle as I wish, but there is virtually no effect on this side of the sine. It's only on the other side when the polarity of the push-pull is correct. So, okay, turn this off. You can see here at the peak of the sine is the switching at resonance, at LC resonance. And this is where the polarity of the square signal changes. So I can only use this side of the falling sine, and in the negative part, it was noted that the pulses goes in counterproductive. The feedback is negative, not positive. So it should be reduced to the 1/4 of cycle in this setup. Okay, thanks for watching.